Let's take a look at a couple of examples, additional examples of using the add WF and the destination bits of W and F. So in this one, the example asks us to state the contents of the file register, RAM locations 12H, and the working register after the following program. So let's step through this. First step, move the literal to the working register 0. So we're going to move 0 to the working register, and in effect that clears that register. The next command says move the working register to the file 12H. So this command, we're going to move or copy the working register contents to the location 12H to clear it. So it also has a 0 in it. The next step, 3, says move the literal to the working register, the value of 22H. Okay, so we're going to load the working register with a value of 22H. Now the next 4 steps, we're going to add those values by moving the value from the working register into the file register at 12 and just sum them as we go. So the next step says add WF12 hex to the file register. We're going to add 22 to the location of 12, which had 0 and was clear, now has 22. The next step says, okay, we're going to add again. Go back, grab that 22 hex, add it to the existing value of 22, and we're at 44. The next add says do the same thing. We're going to add the working register value now, which is 66 and 22, or 44 and 22, so we're at 66. And then finally we're going to add again the working register and the location together, so 22 and 66 gives us a value of 88. So in this case, the program cleared the working register and the RAM location 12 hex in the file register. Then it loaded the working register with a value of 22 hex. From then on, it adds the working register and the location 12 together and saves the result at location 12 hex. It does this 4 times, and at the end, the location 12 hex of GP RAM has the value of 88 hex. 4 times 22 gives 88 hex, and the working register stayed at 22 each time. So you can see that down in the bottom. For each step, as we move through it, the working register stayed at 22, but the value at the location 12 incremented 22, 44, 66, and 88. Let's look at another one. In this one, we're going to rewrite that last example to place the sum in the working register as you add the file register locations and the working register value. So again, we're going to place the literal value of 0 into the working register to clear it, so it's setting at 0. Now we're going to move the working register value into 12, so we're going to add that 0 into 12, and it clears it. So they're both the working register and 12H are sitting at 0. Now we're going to move literal value of 22 hex into the into the working register 22 hex. So now we have 22 hex sitting in the working register. And what will happen is that 22 is going to increment now in the working register, and the address location will remain the same at 22. So we're working it a different way. So we're going to add the working register to the file at 12, and when we do that, we end up with our first value of 22 hex. Now the next step says do the same thing again, 22 to the existing 22 at location 12, and now we're at 44. We do it again a third time. Now we're up to 66, and then a 4th time we're going to add the working register value of 66 to the 22 that's sitting at the location, and we get 88 hex. So this program added the working register and location 12 together and saves the result in the working register each time it sums. So the working register went up 22, 44, 66, 88, and the 22 hex remained at the file location. So a different way of looking at adding and accumulating in different places.